In this video, let's examine motion by taking a look at position and time graphs. In previous videos, we've talked about the language of motion and kinematics, and we've also used diagrams to describe the motion of objects. So let's see what we can learn about the motion of objects by examining the shape of a position time graph. But before we start, why don't we draw a quick diagram that illustrates the motion of an object. So let's draw a line here that could represent a one-dimensional plane, and let's maybe put an automobile on this line somewhere. Alright, so let's take a look at this diagram. We've created a little automobile here, and let's say that this thing is moving to the right. So let's say that our vehicle is moving to the right, and on a number line we would say that that is moving in the positive direction, because if we look at a number line, going to the right is positive and going to the left is negative. So let's keep in mind that in science, positive and negative are excuse me, they tell us something about the direction of an object. Alright, so if we were to, and let's assume for a minute, we've looked at these diagrams before, let's assume for a minute that as this vehicle moves along and it's got a drip, we'll use a dot diagram. If we look at this, we're going to assume for a moment this automobile is going at a constant speed. So if we were to graph that, let's see what that might look like. Alright, so let's draw a graph now. Let's label the different axes here. So on the bottom, we're going to put time as the independent variable, and let's use seconds for our unit. And if this is a position time graph, we're going to be graphing position on the y-axis, and let's use meters as our dimension of measure there. Alright, so as this vehicle moves along, let's say in the first second it goes some distance, and if it's going at a constant speed, in the next unit of time it will go a similar distance, and in the third unit of time it'll go a similar distance, because it's maintaining a constant speed, a constant velocity, I would rather say, because in this case we're moving to the right. So if we look at our graph, this slope would be the velocity of our object, because it has a magnitude, whatever it is. It could be going however many meters per second. Let's say perhaps it was going some velocity like 10 meters per second. But since the slope is positive, that's because the car is moving to the right in the positive direction. So that would mean we have a velocity of 10 meters per second to the right, or even in a positive direction. Alright, but let's take a look. Let's turn this automobile around and see what might happen if we were going the other way. Let me erase this graph, and let's take a look at the slope if we go the other way. Alright, we're back and we've got our car and we've flipped it around. And let's say in this instance that our velocity is to the left. Let's say that we're moving to the left. So if we look which direction that is, that's the negative direction on the number line, because negative was to the left. So what would that mean if we have a negative velocity? Well, let's see. What that would mean is then that we're going in a negative direction. So our displacement would be, we're going towards the zero if we're on the positive side, moving toward the negative. So maybe at some point we have a displacement that's over here at 1 second, and there at the next second, and here at the next second. And if we draw a line of fit along there, let's take a look and see what we might have. We start at some position, and our slope is negative because the direction is negative. And so we could again have some magnitude. We could say that this velocity, if we do the math, maybe we had a magnitude again of something like 10 meters per second, but we're moving to the left in a negative direction. So in that case we would have, take a look, we would have a negative slope. So one of the things we'll learn about position time graphs is we could have a saying that says so goes the slope, so goes the velocity. So when the velocity is negative, when the slope is negative, the velocity is negative. We're moving toward the left. And when the slope is positive, then the velocity is positive and moving toward the right. And we could take a look at one last situation and see what that shows us. So let me clear the page and let's look at one more situation. Alright, in this situation, let's examine the possibility of what might be happening if we're sitting in our car and we're not changing position. Alright, the clock's running because we can't stop time, but there's no change in position. We're sitting in one spot and the car is just drip, 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 dripping oil. Well, depending on where you are on the number line, we would recognize that our position is not changing, but time doesn't stop. So we would end up with a graph that looks something like this. And what would our slope be? Well, our slope is 0. So what that tells us then is the velocity is also 0 meters per second because we're not changing. There's no change in position over time. Alright, so taking a look at my clock here, we're in about 6 minutes or so, and I think that's given you a very brief look at how the shape of a position time graph tells you something about the motion of an object. In the next video, we'll explore that a little bit further. But for now, that is all.